welcome to IWCF Level 4 Surface Stack POV Supervisor Level or Level 4. This course will be delivered within 4 days. The course content is 2 parts, B and B part, principle and procedure, and talking about how to proceed and kill the well, killing operation, about the kick principle. And second level is equipment part, surface equipment part. You will have on last day 2 exams, separate exam, one for B and B and one for equipment part. For B and B, it will be 46 questions in 1 hour and 10 minutes, the time. And for B and B, it will be 64 questions in 2:45 minutes, 2 hours, 45 minutes. This is the time for your exam. If you need to pass, you need to get for each part 70% score. So you will get your certificate valid for 2 years from the date for the exam. Okay. Inshallah, hopefully this course add you some value. You have the kill sheet, you have formula sheet present to Mr. Ahmed, and you have quiz book, and you have exercise book, and I will share with you my presentation to start our course. Are you ready?
Yes, I'm ready, Mr. Hani. Go ahead, please. Thank you.
This is well controlled IWCF Level 4. We already made presentation about ourselves. Some logistic, the time will start according to Kuwait time. It will be 9 a.m. and almost will finish by 15:30. So total hours is 6.5 hours, including half hour for lunch break. Course material is with you. Passport you need to have during the exam for your identification.
Yes.
What is the course objective? Why we deliver or attend this course? First, to increase candidates' operational knowledge for well-controlled procedure and killing operation. How to put the well under control. How to kill the well and resume our normal operation. Second point, to prepare candidates for IWCF service. Our course is talking about service and combined well-controlled examination. Course outline, day number 1, it will be today for principle and procedure, B and B. Day number 2, it will be continuing for principle and procedure. Day number 3, well-controlled equipment. We will have virtual simulator training, well-controlled simulator. Day number 4, it will be revision and the quizzes here in class, virtual simulator exam, and you have simulator exam, you need to pass also with the same percent, 70%, to get your final certificate also with the written or online exam. Day number 5, the last day, it will be final exam. And I think your exam, it will be online, right?
Yes, will be online.
Okay. First point, we'll talk about principle and procedure, B and B, well-controlled barriers. Most of us, or you are working in a drilling site or drilling rigs, so you know about what is the kick and the blowout. This is definition, almost the most common definition you can hear in the rig site. What is the kick and what is the blowout? What do you think?
Yes. Kick is an influx. A blowout is an uncontrolled influx.
Yes, thank you. Kick is an influx of the formation fluid enter the well bore and cause the well start to flow. In this case, your formation fluid can be oil, can be gas or contamination between oil and the gas mixture, or it can be also formation, water formation. So the water can be also kick. Okay.
Understood.
Why the fluid start to flow the well? Because your hydrostatic head here for the mud become less than the formation pressure. So the influx will be inside the well bore. but still under control. So you can close your BOB stack as a surface. You can read pressure at the surface, then you can convert this pressure to increase in the mud weight, and you start to kill the well. The flow out is exit for formation fluid reach to the surface, so it is out of control. So it is an uncontrolled exit of formation fluid reach to the surface. You try to close your BOB stack, you have failure in BOB stack to control the pressure, so the oil and the gas reach to the surface without control. In this case, it is called blowout case. Normally, not all kick situation can lead to the blowout. According to the experimental or experience in oil field, 10% only from the kick, if you not deal or handle in good way, it can result to blowout. And the most blowout which happened from almost 11 years, it is the disaster in Gulf of Mexico, which is deep water horizon semi-submersible.
Yes, correct.
What is the barrier classification? Here we talk about barrier. Something can prevent the flow from the formation. It can divide it to three main categories. First category, primary well control barrier, which is the fluid or the drilling mud, which prevent the influx from the formation come inside the well pool. This is called fluid barrier or hydrostatic barrier. Usually, when you drilling, you drill with mud, the weight or the hydrostatic head or the mud give you pressure higher than your formation pressure. By minimum, according to the API, American Petroleum Institute, put some regulation. You have minimum 200 PSI over balance. You need to have minimum. In some company policies, they can put more than 200 PSI according to the depth for the well, porosity and permeability for the formation, type for well, deviation, temperature downhole, a lot of consideration. If you have failed in the primary well control barrier, so you switch to control the well with secondary well control barrier. This is piece for equipment is called BOB or blowout preventer. You will shut in with pipe ram or annular to stop the flow and control the kick. At that moment, you will record pressures at surface and convert these pressures to mud weight, increase your system with kill fluid, and you start to kill the well with one of the killing methods we'll talk later. Tertiary well control, this is called relief well.
Yeah.
What is the relief well?
You drill a well adjacent to the well that is blown out, and then you try to kill it from the relief well. I think either you pump cement or you try to circulate out through the relief well to bring the main well under control.
Yeah, this is well parallel to the blowout well in same area. You will drill and intersect the kicking zone, and you start to kill the well from the zone, kicking zone, to isolate the well. You can pump cement, heavy mud, or in some cases you can pump junk pits. Okay. This also happened with deep water horizon. They drill two well to control the kicking zone. Here, this another classification, something called procedure or operational barrier. When you are going to monitor the well for any gain or loss inside your tanks, check active or gain in the tank. This is called operational or procedure for your mud system. Physical barrier from its name, something you can see or touch physically, like cement block or BOB or drilling mud, if you can see at the surface and the level is static. Mechanical barrier, piece of equipment that contain the flow from the formation, like BOB or unperforated casing. Barrier envelope, what is the barrier envelope? This is combination or more than one barrier act together to contain the flow from the formation. Like when you are drilling, you have hydrostatic head for the mud, and you have BOB as secondary barrier. The same can apply if you need to, for example, change the one ram in the BOP. So you need to have one mechanical plus your hydrostatic head for the mud. Or in some company, they can add more barriers. This is the minimum requirement to barrier in place.
Yes.
How we can pressure test the barrier? The barrier will not be acceptable barrier till it is past the test criteria or test requirement to consider as a barrier. The BOP in the rig, if you put above the wellhead, you cannot consider as a barrier till it is past the test procedures. What is the way to pressure test the barrier? You have two pressure test types. One is called positive test and another is called negative test. The positive test, you apply with external source pressure on the surface side for the barrier like cement block or BOP more than from bottom from the formation side. At that time, your surface pressure plus your hydrostatic head column above the cement block in the well, it will be more than the formation pressure. So by this way, it is called positive test. And you need to hold the pressure at least for 10 or 15 minutes on that chart to ensure the barrier is holding the pressure so you can continue your operation. In the another way, the negative test is called sometimes inflow test, or in some companies called dry test. You make the reverse thing. You apply pressure from the formation side or the formation pressure. It will be higher than the hydrostatic head for the mud above the barrier. So this type is called negative test. How we can make this one? You can displace the fluid above the cement block to lighter fluid like water. If you are draining with 10 ppg, pound per gallon, for example, you will displace the well to water like 8.3 or 8.5 ppg. At that moment, you will stop circulation and you start to monitoring the gauge at the drill pipe or the pump pressure. If this gauge is still zero, so that means the pressure below the barrier holding. If the pressure is building up as the surface, that means you have leak through the barrier. So you need to replace or to repair your barrier and to consider it is tested according to the requirement. This is the way for positive and negative test. What is the recommendation according to the API to perform? If you have the two options, you will start with positive test or negative test. You will choose only one. What is the best way to pressure test any barrier in the well? Negative or positive test? What do you think?
I think maybe the best is the negative, but negative will take too long. But the positive will be fast. You will know immediately, maybe within 10 minutes or 15 minutes.
Okay, this is according to the time, but you can pressure test with the, for example, with the pressure for the well. So it will be fast also. You bleed pressure above, so the pressure from below valve, it will be higher than the above. So it will be fast in some cases also, the negative test. So
the best will be negative if you have a barrier downhole and if you have set a cement plug or something, then of course the best will be negative because that will really show whether the cement plug has set and is holding. Am I right?
Why you prefer the negative test? Okay, I am agree with you. The negative is the best. Why is not related to the time actually, but is related because this is a test in the direction for the flow. Correct. In the same direction for the flow for formation. So you pressure test your barrier with the same direction for the flow. That's why you prefer negative test or inflow test. Minimum 2 tested barrier in place during your operation. Regarding the pressure for the well, you need minimum 2 tested barrier in place. We need usually to pressure test cement block and liner lab. Liner lab is the top of liner. Okay.
Yes.
Why these 2 critical point in the well? Cement plug and liner
cement plug because it might not set properly. You might have thickening issues. It might not harden. You might not get the proper barrier one. And then on your liner, when you set the liner in the casing, it might not seal properly because it's mechanical. And if it doesn't seal, then the channel will be open. So your liner will be hanging with the open space to the open to the formation below. So these two areas can allow influx if it's not set properly.
This is two communication points or paths in the well pool around the liner lab or below the cement block. So we need to check its integrity. Integrity here, that means you need to verify your barrier is holding pressure.
Yes.
We'll move to talk about pressure concept. What is the pressure we need to talk about? First, we'll talk about hydrostatic pressure, HP. Hydrostatic pressure equation, the units for this course pressure, it will be in unit PSI, pound per inch square, equal to mud weight, it will be in BBG, pound per gallon, by times TVD through vertical depth times factor K, which is 0.052. Okay, this equation you will find you have formula sheet. Could you check your formula sheet? This is first equation in formula sheet in first page, number 1. Equation number 1.
Yes, it's.
You have?
Hold on. Yes, correct. Number 1.
Okay, number 1 is the formula sheet. Pressure equal 0.052 TVD by foot by mud density.
By foot.
Yes.
Yeah.
This is during the rest, during the static condition, without pump running. So if you need at any point to measure your hydrostatic pressure, so you need to know only through vertical depth is not measured depth, through vertical depth related to the pressure, 0.052 and mud weight in the well. Here we'll talk about hydrostatic pressure gradient. The gradient, that means the last equation, two parts or two sides will be divided by foot. So we'll get pressure for each foot through vertical depths inside the well pool.
Yes.
So this is the second equation, pressure gradient equal mud density 5.052. The unit for pressure gradient, it will be PSI per foot.
Yes.
And this two equation is general equation. If you put fracture gradient, you will get mud weight equivalent to the fracture pressure. If you put formation gradient in the equation number 2, you will get the mud weight equivalent to the formation. So it is general equation. Okay.
Yeah, it's correct. Yeah.
If I give you PSI per foot times foot TVD, you will get the pressure at each point inside the well pool on the well.
Correct, per foot, yes.
This is the true vertical depth. This is 2 points, the vertical distance between 2 points regarding the volume inside the containers for the well or the shape for the well. So if all this container filled with the same fluid density, at this point, at the same depth, you will have the same pressure at the point.
Same pressure, yes, correct.
This is difference between true vertical depth and MD, which is measured depth.
Measured depth.
The measured depth, for sure, in highly deviated will be longer than the true vertical depth, because this is the length for the pipe lay on the side for the well. So the measured depth usually we consider if you are calculating volume, strokes for the pump, and time for circulation. But through vertical depth, we only consider for pressure calculation. Okay?
Pressure. Yes.
Let's look at this exercise or calculations. Example number 1, 10 BBG given, calculate pressure gradient. So it will be 10 times 0.052 give you
10 times 0.052.
Give you 0.52
0.52 psi per foot.
Example number 2 given to you at 9,500 foot TVD, pressure gradient 0.65 psi per foot. Can you calculate the mud weight?
Yes.
From the equation number 2, the mud weight.
Number 2, hold on. Hold on. Mud weight is equivalent to, so you just turn it around. So pressure is 0.65. Hold on, wait. Just give me 1 minute.
Yeah, sure. You try.
Pressure is equals to mud weight times 0.052, right? So
Yeah.
you want the pressure is given. You said 0.65,
PSI per
right?
foot. This is pressure gradient. Yeah.
0.65 times 8,500, right? So you get pressure 5525 equals to 10 times. Oh, hold on, I'm confused now. And wait.
Okay.
So pressure gradient, okay, 0.65 times 8,500, 0.65 times 8,500, we will get the 5525 psi, right?
Okay.
5525 psi. That is the total hydrostatic pressure of
Okay.
this at this depth,
Okay.
right? So the mud weight will be, just turn it the other way around, right?
Okay.
Uh, so you got 5525 is equivalent to mud weight times 0.052. So you bring the 0.052 the other side, 5525, divide by 0.052. 5525 times 0.052. No, I'm not getting it.
This is pressure gradient at 8,500 is 0.65 psi per foot.
65.
This is
Okay.
pressure gradient. The equation for pressure gradient number 2, pressure gradient equal to 0.052 times mud weight. If you divided 0.065 by 0.052, it gives you direct 12.5 ppg.
Oh yeah. Yes. Sorry. Yes.
Yeah.
It's a
If you
direct. Yes.
if you
Sorry.
make like what you do, you should use first
Yes.
equation because you get the pressure by
Yes.
psi equal to 0.052 by mud weight times TVD. So you again divided 0.052 by TVD to get your mud
Yes.
weight.
Correct.
This
It's
is
direct. It's PSI. It's PSI per 0.052.
psi per foot divided by
Yes.
0.052,
12.5
12.5.
ppg.
Yes.
Yes. Okay. Correct.
Okay. What is the formation pressure? What is the definition for formation pressure? If we said formation pressure at this zone 2000 psi, what is the meaning for 2000 psi?
You can say it's the overburden pressure plus the formation fluid, whatever it's down in net depth, plus the overburden is the formation pressure.
Yeah, this is the pressure act on the fluid trapped inside the pore space in the well pore or inside the pore space in the formation. It gives you how much the formation, the pressure for the formation. Usually 90% for the formation worldwide is water or salt water or water formation water. Okay.
Yes.
So we drill to get oil and the gas from 10% only from the formation. We drill over the worldwide. So according to calculations or measurement, the normal formation pressure, which is the water formation or salt formation, equal its gradient to 0.465 psi per foot. This is the gradient. If you are going to drill at any area with the formation pressure higher than this value, its gradient higher than, so your formation will be considered in the
abnormal pressure.
Yellow area here, abnormal formation pressure. If your value less than, it will be depleted or weak zone or subnormal formation pressure.
Yes.
So this is our reference. The measurement or the average for this value is taken in the Gulf for Mexico, okay, in US.
Okay.
So let's look at this calculation. Example number 1, please.
Okay. Formation pressure 1,200 feet. TVD is 601 psi. 601. So
Mud weight
601 divided by 1,200, you get 0.5.
Okay. Mud
0.5
weight.
psi.
Yeah, mud weight. The pressure for this formation should be
Oh, you want, okay, 10 times 0.052 times 1,200. 624 psi.
we need to know the pressure for the formation is normal, abnormal, or subnormal, A or B and C.
624 minus 624 minus 601. Am I right?
No, you get your formation gradient as you calculated, and you
Okay.
compare with 0.465 psi per foot. If this
Yeah,
value
so
is
you
higher,
just take 601 divided by 1200.
yeah.
You get 0.5008.
So this one is higher than
So it's not subnormal. It's slightly above subnormal.
Is abnormal.
465.
465. So it will be the formation pressure will be abnormal.
So it's abnormal.
Abnormal, right?
Yeah, it's abnormal. It's slightly higher than 0.465. So it goes into the abnormal. Yes.
So you need here to calculate your gradient and to compare with the value for 0.465 psi per foot formation water. Example number 2.
Yes. What is meant by abnormal pressure related to the fluid pressure? What is meant by abnormal pressure related to the fluid pressure information? Oh, okay.
Sorry.
Hold on. What's the question?
Here.
What is abnormal pressure to the fluid pressure? Okay. The excess pressure is need to be applied because of okay. C.
The formation for
the formation
your
fluid
fluid,
pressure is that exceed formation water hydrostatic pressure,
which is the normal formation pressure. Okay. What can happen to the formation to convert or change from normal formation pressure water to abnormal formation pressure? Its pressure will increase. What condition can happen? This can happen according to geological conditions, or earthquake or something like this. So no force from human. So this can happen naturally. Convert your formation from normal formation pressure water to abnormal formation pressure. This is the first reason for kick, because increasing your formation pressure will decrease the overbalance in the well. So decrease the overbalance, that means you can go to underbalance situation or kick situation. So what do you think the reason for that?
Trap formation water, trap gas, overburden pressure, different kind of sedimentation, pressure of different kind of reservoirs, overlapping, like connate water or ancient water systems like brine inside the formation.
Okay.
And gas and hydrates.
Okay. First, thank you. First one, worldwide, first reason, under compacted shale or sand. This is the first reason. If you look here, the formation here is formation water. Normally, with increase in depth and compaction, you press inside the pore space. So the water starts to release to the upper formation from the pore space. This is called dewatering process. But if you have here sealed area, okay, like this one, you will trap the formation or the water inside the formation below this trap. So if your trend for your gradient, like here, the green one is normal. So at this moment, here it will be increased in the trend. It will convert to abnormal formation pressure.
Abnormal pressure ramp, correct.
Okay. Second reason, as you said, the gas cap broke. According to this is coming from seismic survey or exploration. You have natural in the rock, you have sealed area or gas cap. Okay, a cap broke here. So the gas, you have gas inside the formation. So the gas, according to its density, is lighter than the formation. So it will migrate up to the top for the cap broke. So the formation from below or around start to compress this gas to the maximum at the top point here. If you are put your rig here and you are going to drill in this area, so you drill and your formation equivalent to 0.465 psi per foot, normal formation pressure. So you need to have your mud weight equivalent to this value. But if you put your rig here and you try to penetrate the gas cap here, you need to check what is the pressure here, which is the maximum pressure at the top for the gas cap. So you need to increase your mud weight according to the pressure value here. So if you need to give this value for the pressure, and this is one question for level 4 in the exam, you will get the pressure to the bottom for the gas cap first, which is normal formation pressure. Then you get the pressure inside the gas cap probe area, which usually gradient for the gas assume 0.1 psi per foot by the length or the height for the gas cap. This two value PF minus PG, it will give you the pressure, the maximum pressure at the top for the gas cap. When you drill here, you will get lower pressure when you penetrate the gas cap. Usually, this two questions can come in the exam. First question is calculation. We'll solve together if you need to get this pressure. So you will convert this pressure to equivalent mud weight and you start to increase mud weight at this point to penetrate the gas cap without any problem. So, or second questions can come, why the maximum point here is the maximum pressure for the gas cap? Because the gas is lighter than the water and it will be coming to the top and it will be compressed at the top for the gas cap. Usually, sometimes the cap probe or gas cap probe can be in shallow area, high pressure gas cap. At that moment, you will drill with diverter and you will divert the gas and burn it away from the rig floor or from the rig to save this. Third reason is called surcharge formation. From its name, something charge in the formation. If you drill one well and you completed producing from that one, this is the first well in the left. So if you have bad cement job in the last casing behind the formation, and you have the lower formation is higher in pressure than the upper formation, the white one. So this lower formation will start to communicate or charging the upper formation with the pressure. So if you are going to drill another well in this area, you will get high pressure when you drill this zone because its pressure becomes charged. So this is cause or for kick situation.
Abnormal pressure.
Yeah. If you look for this, for example, if this pressure is 2000 psi, it's equivalent mud weight like 8.9. So charge it to 2500, you need to increase mud weight to overcome kick situation.
Correct.
Another natural cause is called fault. You have from earthquake or movement for the earth. Or tectonic movement, you have fault in this area. So the formation will become to shallower depths with its same pressure inside the formation. So you need to consider when you are drilling in fault area. So you need, if you know this area has fault, so you need to consider to keep your kill mud weight ready in the system while drilling this transition zone or this fault to not take any kick or blowout situation. The last reason here is artesian well. What is the artesian well? You know?
No, not really. Artesian, no.
Okay, you have connecting zone. You said that there is connecting zone. High porous sandstone. There is source for water continuously source like lake or rainfall. So this lake is charged your formation connected to downhole with pressure. and your rig in the level is lower than the level for the lake. So all the time you cannot overcome this difference between the two levels. So if you are this head. So if you are going to drill in this zone, you will get from naturally flow from the water from the formation. So what you should do, you cannot work by this way. You cannot drill well with kick all the time from this zone. So you should take action. How you can solve this problem or this issue?
If you can drill through, you can drill through in case of this zone. Drill in case of this section, and then go to the next section.
So you can first consider to run cement shallower to cover this zone.
Okay,
Okay, this is one solution.
And drill through.
And drill through. But here, your plan may be changed to have smaller at the end casing instead of like you end the well with 7 inch, you will end with 4.5. So it will affect your production.
Correct. It will affect your production. Yes, correct.
You can increase your mud weight, but keep in consideration if you have any weak zone above, or you can consider setting cement shallow. Okay, another plan. Or you can change your place for the rig to be in higher level than the lake source or the source for the water. That if this is possible to make, it will be also another solution. Okay. Look at this example.
B.
Usually,
water source located higher.
Usually an IWCF exam or exercise, you can ask you about multi-choice answer. So you can ask you about 2 or 3.
But then this is artisan effect. Artisan effect means only B, right?
Yeah. But for your information, if you answer only from 2, only 1, you will get 0 score. You need to answer both correct. Okay. This is a multi-choice. That's why we need to focus on multi-choose questions and 2 answer or 3 answer. Because if you have 3 answer, 2 is right and 1 is wrong, you will not get any score. You will get 0. Yeah. Okay. After that, we'll talk about formation characteristic or properties. First one is talking about the porosity. What is the porosity? The porous media, or how much volume inside the porous space can the fluid fit. This is percentage between volume for voids inside the rock divided by the percentage total for the volume for the rock, including grain and porous space, usually in percentage. Okay. If you look at this graph with depths, what will happen to the porosity? When you drill, it will reduce because of cementation and compaction.
And compaction.
So if you look here, you have shale and you have sand here. At 10,000, your shale porosity is less than your sandstone porosity. That's why we can produce from the sand and we cannot produce from the shale. Because shale have high porosity but low or zero permeability. That's why it's trap formation. Another characteristic for the formation is the permeability. Here is the how much the porous space is connected to each other. The ability for the rock to going through connected porous space and coming inside the whirlpool. This is the meaning for permeability. The same like porosity with the depths, the permeability will going down also or decrease. The permeability unit is regarding to unit called Darcy, or millidarcy. The Darcy is the scientist who discover and make researches or on the permeability concept. With the depths here, if you look at 10,000, you will have shale 0 permeability, but the sand still have porous media. Why we need to know about porosity and permeability in this course? This is well control course. It's not production course. but we need to know about porosity and permeability. Why?
You need to design. You need to design your casing points. You need to design your fluid type. You need to design based on mud weight, and you need to design based on the factors. Because if it's permeable, then you can lose fluids or cement. If it's porous, also same. And if it's permeable, you can have connection between anything that's in the reservoir into your wellbore.
Okay, this answer is good for the well design, for engineering course. It's not for well control course. For well control course, okay, does the permeability affect your kick?
Yes.
This is the point here.
Yes,
High permeable zone give you at the
yes,
same time compared to low permeability too much kick volume inside the well pool.
correct.
So
You will get yes, correct. Yeah.
the first point will affect your kick volume. It will be not porosity. It will be permeability. The porosity, yeah, it is measured the volume for the kick or the fluid inside the well pool. But if your permeability is zero, no connected path, so you will not get kick from this formation. But high permeable zone, this is give you higher kick volume inside the well pool. So it will make your well control operation more complex.
More challenging,
yeah.
more complicated. Yeah.
Yes.
Yeah.
After that, we'll talk about static and dynamic bottom hole pressure. When you start or stop your pump, what is read at the bottom hole for the well? What is the meaning for bottom hole pressure?
Bottom hole pressure is the pressure exerted at the bottom of the hole because of the drilling fluid column.
Okay.
And any pressure exerted on that column with your pump switched on. That is dynamic. But static will be with your pumps off, just the column.
Yes.
Dynamic will be with your pumps on. The pump pressure plus the hydrostatic pressure will give you your bottom hole at the bit pressure.
Yeah. So this is, thank you. This is the bottom. Any pressure exerted on the bottom for the well. During the static condition, it will be only equal your column for mud weight. In dynamic, you will have annular pressure loss, ABL, acting plus the hydrostatic hit for the mud on the well pour or on the formation. At shut in, it will be hydrostatic hit for the fluid plus any surface pressure during the shut in situation. Let's look here for the mud circulation system. This is the mud pump. Start to take mud to the standby and then down the string, out from the pit back to the surface with 0 atmospheric pressure, back to separation system, back again to the active system. So this is closed cycle to monitor any pit gain or loss during drilling operation. Here, if you have this example, you have well, vertical well, 10,000 TBD, mud weight is 10 ppg, and the pump is shut off. So if I put gauge on the bottom here in the static condition, what is the bottom hole pressure will be? So
mud weight multiplied by depth.
By 0.052.
By 0.052.
It will give you 5,200 psi.
PSI.
If I start to your pump, if you're running your pump at 80 SPM stroke per minute, your pump pressure now is reading 2,600 psi. I have a question. What is the meaning for pump pressure? What is the meaning for pump pressure? If I said pump pressure 2,500 or 2,000, for example, what is the meaning?
That is the gauge pressure at the pump output.
Okay. What is the meaning for this value?
That is the true value coming out from the pump. It's not including all the frictional losses down the hole yet. It's exactly at the pump exit. You're getting maximum pump pressure at the exit.
Okay. Why we need this value? If I change, for example, the string inside the well, this value will be changed or not?
No.
Sure.
Your pump pressure, string volume. Oh, okay, no. It's a closed system, so it should not, because your output should be fixed, right?
Okay, for
output
another,
on your
I will ask you with another way. If I have 3.5 pipe in the well, I change it to 7.8 OD, to 7.8. Okay.
right.
Your pump pressure for circulation now, it will change or not?
It will change
Why?
because your friction losses are different. Your volume has changed.
Yes. So this value is related to the friction inside the system.
Okay. That means the output that you see at the pump gauge, the output that you see at the pump gauge is dependent on what it's pumping through. Is that what you're saying?
Yeah. Yes, this is what I mean. Again, look with me again.
Right.
You have now, okay, let's look at this system now. You have 2,600 PSI, 80 SPM, like
Yes.
8 barrel per minute.
Yes.
Okay. You have surface line here. You will lose some pressure due to the friction between the wall and your mud. So
yes.
for example, the red value here is the loss.
Let's say 100. Yeah.
100 PSI, for example.
Yeah.
So if you put the gauge at the beginning for the drill string, you will read 2,500 PSI. You will lose only 100.
100.
During drill string or drill pipe, you will lose, for example, 400 PSI.
Okay.
So at the beginning, for the drill cooler or bottom hole assembly, you will have 2,100 PSI.
Yes.
You lose more 500 PSI in the drill cooler, more friction, so more loss compared to 400. So at the nozzle, the pressure for the pump 1,600 PSI.
Yes.
The remaining.
Yes.
According through the nozzle for the pit, you will lose 1,300 PSI.
Yes.
So the remaining 300 PSI at the bottom for the well. This 300 will be the pressure you will lose through the friction in the annulus area. It will be 300 PSI.
Yes, correct.
Okay. So the 300 PSI is called annular pressure loss or ABL. Simple. Okay. So if I change the size for the drill pipe, it will be less or more friction. So your pump pressure will be changed, okay, value with the same SPM.
Yes, correct.
Because if
your pipe sizes are changes.
If the pipe will reduce, more friction, it will be through the pipe. Usually the friction, it will be in the opposite direction for the flow. If you are going to flow down, your opposite direction will be resist to stop your movement.
Yes.
So all direction for circulation here during drilling, it will be in the upper section like this, in this side, or up here, or up here, or through the nozzle up. But only annular pressure loss will act down in the direction for the down on the formation. So your flow will start to flowing up in the annulus. Annular pressure loss will be in opposite direction. So it will be act more pressure on the formation during circulation. So the only factor will affect on the bottom hole pressure during circulation, it will be annular pressure loss or the ABL value.
Yes.
Okay. How we can calculate the ABL? There is calculated or complex formula to calculate the APL, but for this course, it will be given for you time, the APL value.
Understood.
Okay?
Understood.
If you look here in this system, you will find actually 0.5% or 50%, sorry, 50% to 60% from the pump pressure value you will lose on the nozzle for the pit.
Yes.
And usually, rule of thumb, if you need, for example, to assume annular pressure loss in the well, usually it will be 10% from this value for the pump.
Okay.
Okay, this is the rule of thumb from trial.
Okay.
Around 10% maximum from your pump pressure value. Okay.
Okay.
I will put now a gauge on this example on the bottom, and I need to know how much the bottom hole pressure now during dynamic or circulation. So it will be equal the static, which is the column for the mud, 5,200 psi, plus the value of the APL, annular pressure loss. So your pressure now have more pressure, the bottom hole for the well have more pressure equal to 5,500 psi compared to the static condition. When you shut down your pump, you lose your ABL, it becomes zero. So you back again to static condition, which is 5,200 psi pressure on the pump.
Correct.
Okay? Let's look here at this example. You have formation pressure 5,300 psi.
Yes.
In the same well, two well.
Yes.
And the same well here, one is static without circulation, and one is dynamic condition.
Yes.
Bottom hole pressure here is equal to 10,000 foot times 10 times 0.052, 5,200 psi.
Yes.
Here, annular pressure loss is given 250 psi. So here, bottom hole pressure 5,450 psi.
Right.
The first situation in the left here, zero pump pressure.
Yes.
The well is under kick situation.
Yes.
But when you are starting your pump 3,000 psi here, your pump is running. Your bottom hole pressure under control, no kick situation.
Correct.
You know the reason here?
Because you have the additional pressure, the equivalent circulating density. The ECD is higher with your pumps on.
Because when you are starting your pump, you have friction, the annulus called APL, acting more pressure on the bottom for the well. That's why when you are drilling, your tank is at the surface is static, no loss, no gain.
Correct.
But when you stop your pump during drilling for any reason,
you can see flow.
To make connection.
Yeah.
Okay.
Connection, you can see influx.
You can see the flow start coming to your tank. Why? Because of the APL value. So what you will do in this case, you will add the APL value to convert to the mud weight and add to your mud system. By this way, in static condition and dynamic condition, you will have your bottom hole pressure higher than your formation pressure.
Yes.
This can happen in some formation. Its fracture pressure is low, so you cannot add more overbalance in the well. Only you can add the overbalance equal to the APL value.
Yes.
Okay.
Yes.
From this point, you will have another definition. It's called equivalent circulation density, or ECD.
CD. Yes.
ECD. This is equation you will find in the formula sheet.
Number 3.
Equation.
Number 4.
Number 7.
Number 7. Okay.
Equivalent circulation density with BBG equal to original mud weight plus the APL value. You convert to mud weight divided by TBD for the well times 0.052.
Yes.
According to the well control or the IWCF, if you are going to write the final answer for the mud weight, you need to have only 1 decimal after point mark as a final answer. Okay. So you can rounding up or down according to what you are going to calculate. Now we are calculating ECD. So what do you think you will round up or down this value?
I will round up or down. I will round up.
Why?
Because I will give myself some margin in case of any losses or friction losses or anything.
You need to be because you need to be overbalanced over the formation pressure. You will be in safe side. You have safety factor. So, for example, if the value at calculator 10.925, what is the final answer? It will be
10.9 heavy. If they say in the field, they will say 10.9 heavy.
Yeah, heavy in
API
This is in gas well.
Yes. 10.9. You can round it up to 11, I think.
Yeah, you round up to 11.
Yeah.
For example,
11,
if it is 9.856, so the final
yes.
answer will be 9.9 bbg. Okay.
Yes, correct.
This is the first items to round up during the course, ECT.
Yes. Yes.
Effect on pump pressure. What is parameters can change effect on the pump pressure value? It's changing for mud weight inside the well pool.
Yes.
What do you think if I'm asking the mud engineer in the rig
Yes.
to increase the mud weight from 10 bbg to 11 bbg? What
Yes.
will happen to the pump pressure during the cycle after
It will go
you
up.
circulate? It
It
will
will
go
go up.
up because mud weight more viscosity, so
Yes.
more friction, so more pressure
Yes.
at the pump.
Correct.
The equation for that one, P2, the new pump pressure, equal P1 old times mud weight new divided by mud weight old.
Yes. Yes. Okay. Yeah.
Okay, this is equation you will find.
Yeah.
Number
It
10.
is slow. It is slowly coming, Mr. Honey. Very slowly, you know. As you are talking, it's coming very, very slowly, you know.
Yeah,
one by one.
But you still have some memory for
Yes.
that for the
Yes.
course.
Yes.
So equation number 10, if you look at the formula sheet.
Yeah, equation number 10. Yes, sir. Yes.
This is approximate equation.
Correct.
New pump pressure with new mud density equal old pump pressure by new mud weight divided by old mud weight. For example,
Yes.
here at constant SPM, you hold your SPM here.
Yes.
Not change. So you
Yes.
only work with one parameter, changing the
Yes.
mud weight. So here,
Yes.
your old pump pressure 2,600 psi, you increase mud weight from 10 to 11. Can you calculate this value?
Yeah, so you take 11 over 10, multiply by the old one, 26. So 11 divided by 10, multiply by 2,600. 2860.
2860. And
Yes.
usually pressure value, it will be correct number without any fraction in that sense.
Correct.
Okay. But here the
Understood.
pump pressure is not critical value. The critical value it will be for killing or fracture pressure. Okay.
Yes.
Another parameters, you will change your stroke for the pump. You will increase your pump rate or decrease.
Yes.
So what will happen when you increase your strokes for the pump? That means more input in the well, more output, more friction in the system. So for sure, your pump pressure will be jump up or will increase. The equation here, approximate, it will be pressure new equal pressure old times stroke per minute new divided by stroke per minute old, all by 2 or square. This equation, it will be number 9.
Okay.
Here we hold the mud weight, okay? The mud weight will not change.
Mud weight is constant and the strokes per minute is constant also.
We play only in one parameter.
Yes.
Okay. So can you also calculate that
so you
one?
take 100 divided by 80 and then you squared and then you multiply by the old pressure, which is 2600. 4062.5 to 4063.
Okay. So 4063 psi.
PSI.
So I have one question here. What will happen if I double your pump rate? If I double the pump rate, what will happen to your pump pressure?
You will increase. It can either pop off at your pump, your pump will pop off, or you can fracture the formation at the bottom, either one.
Okay, what will happen, the value for your pump pressure if I double the pump rate?
If you double the pump rate, hold on, it'll go up.
How much?
To 680. It should be double.
No, it should be 4 times because
4 times.
of a square. The equation
yes,
square.
correct. Sorry. Yes. 4 times, yes.
If you reduce to the half, your pump pressure will be dropped to quarter because of
Yes,
square in the
because of the
equation.
square, yes, correct. So if you double it, correct, it will be 4 times.
Okay.
So that'll be too high.
Yeah, you can try this. This equation come from trial in the actually in the location. That's why it's
Yes.
called approximate equation.
Right.
Okay.
Right.
Look at this example.
Yes.
Calculate the new pump pressure, old mud density, new mud density, and old pump pressure.
Yeah. So it's 10 old new mud density divided by old mud density times by old pump pressure 1850 1911 psi.
Okay. Second one.
Mud pump running 30 SPM 1000 TVD. Calculate pump pressure when the pump rate has been increased to 35 SPM. With the system pressure loss 30 SPM is below surface line 100. Okay. So you take hold on, mud pump running at 30 SPM. You have 30 to 35, right?
Yes. I need the new pump pressure at 35.
You need the new pump pressure. So it's 35 divided by 30 squared plus the old pressure.
Where's all the pressure value?
So old pressure value you take hold on, where is the pump pressure? Hold on, so we go to equation. I'm missing something here. Hold on, Mr. Hani.
No, nothing missing.
No, I'm missing something. Hold on.
Okay.
So old pump pressure.
They give you the pressure loss at 30 SPM, right? Values.
Hold on. Yes. Old pump rate 30 SPM, yes.
The summation for the pressure loss is the pump pressure.
Yeah, okay. So you
Right?
just add up all this, yeah, surface line.
Plus drill
Yes,
string,
correct.
plus nozzle, plus under pressure loss. This is the meaning for pump pressure we discussed from a few minutes.
Yes, sorry. 2600
Yes.
psi. Right?
Yes.
So calculate pump rate investment. Okay. So you take the 35, the new divided by old 30 squared and multiply by the new pump pressure, right? 2600.
Yes.
You get 3538.8, 3539.
Okay. Okay. Clear?
Yes, clear.
Okay. After that, we'll talk about kick occurrence, when the kick can be happen. The kick can be happen in two conditions. When your formation pressure increase, your overbalance decrease and you can go under balance situation, or your hydrostatic head column for the mud reduced for many reasons. Here we'll talk about what can happen for the formation column to be reduced. What is the reason to reduce in the hydrostatic head for the mud? What do you think? What is the reason?
Losses is one.
Losses. Does any losses can lead to kick situation?
Yes, definitely.
Any type for losses can lead to kick?
Not all. If you have a higher pressure zone above your drilling zone, and you're losing at the bottom, and you're going under balance above, you can introduce an influx.
So not all. It is depend here on the how much you lose your level inside the well, plus compared to the formation pressure value.
Correct.
Okay, so this is first reason is the losses.
Yes.
Okay, what also?
Failure to keep the hole full, gas cut mud. You know, you have gas coming in, your mud weight is not true at the bottom anymore. Your 10 ppg is now becoming 9.5 ppg because of gas in the mud. What
Okay.
else? Formation fluids, same thing as gas, lighter fluid coming in. What else? What else?
Yeah.
What else? Maybe reduction in ECD also. If you got one pump down, no, that's not column. That is something else. That is losing ECD because of one pump down. It can happen also.
Losing
And also,
ECD, that means you lose the mud weight in the well. Is related to
yes,
the mud
you lose
weight.
the mud weight in the well. Maybe one pump is down, you still continue drilling on one pump, and then you're losing ECD. And also with your mechanic, you are tripping out or tripping back in, and you are maybe back reaming too fast. One stand on connection or something. Maybe before you make one
It's
connection,
called the swab and search.
a swap and search. Maybe you are pulling back too fast to make a connection, and
Okay.
search and then swap again.
So you are
Maybe
very good.
yeah, maybe
Sir,
driller is not paying
you remember all now.
so driller is not paying attention. He's not listening to company man.
Okay. Yeah, as you said, first is insufficient drilling fluid density. For
Yes.
any reason, you don't mix the required mud weight, or
Yes.
your mud weight contaminated with diesel or water,
Water, yeah.
or your calibration for
Of mud balance is out.
mud
Yeah.
balance is not okay. So
Correct.
you pump from wrong tank. It's not
Yes.
correct tank.
Correct. Yes.
So
This can
you will
happen.
have insufficient drilling fluid density. So the kick
Correct.
will happen. Second point is the drill fluid cut or gas cut or water cut. Here,
Yes.
when you drill, you have dissolved small bubbles from the gas start to mix with your mud, especially
Fluid. Yes.
oil-based mud. So
Yes.
it is dissolved inside your mud. If you ignore in the first, its effect will be less in your hydrostatic head inside the well. But when you
Yes.
circulate many times without any action, the gas behavior start to expand and coming out from the mud.
Correct.
So you will have
Correct.
more reduction in your hydrostatic head for the mud level. So here
Yes.
you will go to underbalance or kick situation.
Yes. Yes.
What is the action you should do if you find gas cut inside the drilling density or fluid?
First things first, gas cut mud, you need to have a pressurized mud balance to make sure whether you're losing any margin on bubbles.
Okay.
So you check the mud weight, and the best thing to do is when you stop drilling, observe for flow. If you have some flow coming back, or actually even if you don't have flow, you should start increasing the mud weight to hold down whatever that's coming in from the well.
So the first option, you increase mud weight.
Yes.
Also, if there is no kick
Yes.
to compensate the reduction. If it is possible to not go to losses, okay?
Yes.
This is option. What is the first action you should do with the gas cut mud? You need to
Yes.
run vacuum degazzer as a surface. You need to run vacuum degazzer.
You need to
Separation.
run your degas, your degasser unit. Yes,
Yeah,
correct.
yeah.
You run your
Degazzer.
degasser and make sure that the
You
separate
run
bubbles are
the
coming out.
degazzer at the surface to separate this small bubbles out from the mud. So you start to circulate only clean fluid or clean mud.
Correct.
Third reason is the loss of circulation.
Correct.
But not all
Yes.
losses can lead to the kick. It is depend on the pressure for the zone and how much or far the level drop inside the well. You can manage this one. You can put cement plug, or you pump LCM,
Correct.
or you can drilling the blind with mud cap system from the annulus. This is depend on the situation or what is the zone you are drilling to. Number 4 is the responsibility for the driller. Failure to keep the hole full during tripping. You have trip tank. You need all the time trip tank running to the well from annulus. So you are recording and follow your trip sheet to control your hydrostatic field inside the well. Number 5 is called swapping and surging. That swapping happens when you pull out from the hole. the surge when you are running too fast. There is some condition for swapping and surging.
Yes.
We'll talk now. And there is transition zone. The transition zone, the area where the formation for the pressure for the formation start to going up, start to coming from normal to abnormal formation pressure. In this area or transition zone, you will find some parameters or some signs that give you indication that you may go to under balance situation. Okay. About the surge and swap pressure, usually the swap is called minus pressure or negative pressure. Momentary reduction in bottom hole pressure. The reason is pulling out too fast. You have a small clearance between your hole and your assembly, bottom hole assembly. For your information, the swap can happen in open hole and inside closed hole also. Okay. And you have ball pit for stabilizer.
Yes, correct.
You have high gel or viscosity mud. The high viscous mud will not give time for the mud to coming and fill the void space in the between around the pipe. How you can determine you have a swap inside the whirlpool? For example, we're pulling out of hole 5 stem. And
the hole is not taking enough fill if you pull too fast. If you pull too fast, you're not the fluid from the trip tank is not going in fast enough.
Yeah, determine with incorrect filling up. Incorrect fill up, that means when you are pulling out for hole, for example, your trip tank was 50 barrel. So after 5 stand, you must fill the hole, for example, with 5 barrel. If you find the tank is 45 barrel, that means everything is fine. The hole is static. But for example, if you pull 5 stand and your tank is become 47 only, that means you take 3 barrel instead of 5 barrel to fill the hole. In this case, you know that you have swapped kick or swapped gas inside the hole or whirlpool.
Yes.
Okay. So what is the action you should do if the driller notes that there is a swap condition inside the whirlpool? What is the action? You are now pulling out in the midway or in the midway inside the well, like at 5, your well is 10,000 foot and you are in 5,000 foot now. And your trip sheet is looking that you have some swap effect inside the whirlpool. What is the action the driller should do? What do you think?
I think you should stop pulling out. Observe the well. Stop pulling out. Stop pulling.
Stop pulling out.
Observe. Fill up the well with the trip tank.
If you stop your movement, you will back to normal condition, right? You will minimize.
Stop pulling out.
Yeah, when you stop pulling out and make flow check, you will find everything is fine because you already stopped the reason that caused the swap to happen. Right? At that moment, we can continue pulling out, or what you should do if your well is static now or flow check is negative.
If you stop pulling out and sorry, Masani, I don't know why these people are calling me. Hold on.
Okay.
If you stop pulling out, you will give the well enough time to the trip tank to fill up again with mud. And by the fact that you stop and you flow check, you already know whether you have overcome the swabbing issue. You should be able to know like this. Is that your question?
Yeah, at that time, what you should do, you will continue pulling out, or you need to run inside the well again or you need to circulate at this point, or what you?
No. You need the best if you suspect an influx. If you suspect something at the bottom of the hole, then it's best to run back to bottom.
Yes.
And circulate from bottom again. That's the best thing to do. If you suspect something has come in during your swap, you go back to bottom. You establish circulation. Yeah.
This is the must you should do. Here it is must. You need to run back to the bottom again to circulate bottom up. Why? Because if you don't make like this and you continue pulling out, there is a swab cake or gas at the bottom. The gas will start to expand
at the bottom.
Yeah, at the bottom, migrate up, and to sure you are going to kick situation. So if you're going back again to the bottom, you will circulate the gas out from the hole with the same mud weight. You don't need to increase your mud weight in case of swabbing, because the original mud weight will be able to control the well. That's why it is called momentary reduction on bottom hole pressure. Because once you stop the reason, you will back to normal situation. But if your float check is positive, what means positive? That means you have kick. You have the well is flowing with the pump shut off. In this case, you will shut in the well immediately without any delay at the point you are in. If you are at 1,500, you will not run in back to the bottom. If you are sure you have kick, you will shut in at 1,500. After that, you control the well first. After that, you will deal to go back to the bottom to kill your well. Okay. The surge, the same reason for swab is the same reasons for the surge. By the surge is momentary increase in bottom hole pressure. When you are going run back to the bottom, especially when you are running with float valve in the bottom, like casing run. If you're running too fast and small clearance, so you make surge with the fluid in the bottom. You increase your bottom hole pressure. That's called positive pressure. At that moment, why increasing bottom hole pressure is fine for kick, like surge. Why? Your bottom hole pressure is increasing over your formation pressure. Why it is problem or why it is indication for kick?
No, it's not good. You will fracture the formation.
Yeah. If you have loose zone or weak zone, you will exceed the fracture pressure.
You fracture and
After fracture your formation, you have losses. From losses, you have drop in your hydrostatic head.
And then you will have
you may go under balance and you have impacts. That's why post-surge and the swab is related to kick occurrence. Okay?
Yes.
Here we'll talk about wet and dry tripping. From well control view and safety, what is the best option to go out from the hole? With wet or dry tripping? What do you think?
The best way is to trip wet.
Trip wet? What means tripping wet?
To trip wet. You slug. Wet means you don't slug the pipe. You don't dry the pipe. You trip with the mud in the pipe, and you pull out slowly.
This is the meaning for
wet. Dry is you slug the pipe and you pull.
Yeah. So what is the best?
I think so. Yes. Wet is with. Let me think. Wet and dry tripping. If you dry trip, you slug the pipe and you pull. Then it becomes like a plug, right? You might swap. If you wet pull, your pipe is wet, so the pressure is balanced inside and outside. Am I right? So if you pull wet, it should be better. You don't swap the formation. You don't swap the formation if you pull wet. If you dry the pipe and pull, you can end up swapping the formation if you pull too fast.
Actually, is not correct. Let's say the question was another way. Okay. Compare between wet and the dry tripping. Okay. If you pull 5 stand wet and 5 stand dry, How much mud you will lose in which case? You will lose more mud from the well. In wet or dry trimming?
If you pull wet, you will lose mud on the surface because when you break pipe, you will lose
so
you will lose a connection.
You will lose
more. Yeah, okay,
no.
So it's better to.
You get my
when
point?
You pull wet, yes.
You pull,
yes, correct.
You lose more mud from the hole. So that means more level drop inside the well. That means you can go under balance easily, right? So dry trimming, that means when you pull out from the hole, you will lose only the thickness for the metal, which is called metal displacement for the pipe. You need to compensate this value.
Only displacement loss, correct.
Yeah, but when you pull wet, you lose the internal capacity for the pipe plus metal displacement.
Internal capacity of the pipe. Yes, correct.
That's
two losses.
Two losses. For dry trimming here, your pipe from inside is empty. So here, the volume you need to add from the trip tank and annulus when you're running the trip tank all the time while pulling out
is displacement
equal
only.
to cold open-end displacement or metal displacement or steel displacement.
Yes.
Which is
metal displacement. Yes.
OD squared minus ID squared by 1029.4 give you parallel foot for the metal displacement. Usually in the exam or exercise, it will number given to you direct. You don't need to calculate. Okay. This is for dry trimming. Also, according to the safety, it will be more safe for personnel or crew in the rig floor to pull dry, to not make the rig floor wet,
because,
especially.
You don't break pipe on surface.
Yeah, especially if you are working with oil-based mud, the risk for slippage it will be more.
Yes.
Okay.
Yes.
Wet trimming, that means you need to compensate in the well each stand you're pulling out the closed-end displacement, which is internal capacity plus metal displacement. Here, if you look here, this is cross-section in the pipe. This is capacity for the pipe. This is metal displacement.
Yes.
Pipe metal displacement plus pipe capacity, it gives you the closed-end displacement. Okay.
Closed-end displacement.
Yeah. Trip tank. This is small tank. Usually, capacity 20 to 50 barrel. Usually in the rig you have 2 trip tank. Okay. One for oil-based mud and one for water-based mud. Okay. The trip tank usually running during tripping operation. So when you are going to trip out, you start your trip tank pump here. So there is line sucked from the tank, from fill line down to the annulus while pulling out your string. And the return here or the flow line will back the fluid to the same tank. So this closed cycle while pulling out or tripping in. To measure this tank from losses or gain during tripping. The same like the active tank in the drilling operation. You have measurement here to measure the float or the level inside the tank. The level start to drop when tripping up or out because you compensate the metal displacement or closed-end displacement inside the hole, and while tripping in the metal displacement will be out or closed in, so the level will be increased inside the trip tank. From this tank calculation or measurement, the trip sheet can do by the driller to monitoring your tank during tripping operation.
Yes.
Here, for example, you are tripping out from the hole, your pump is on, all the time you line up to the annulus to fill the metal displacement. So the measurement here return to the same tank. Here, if you start volume by 15 and 5 stand pulling out, you will lose, for example, 5 barrel. So you will finish by 10. For example, if the driller after 5 stand pulling out, find the trip tank less than 10 barrel, what this indicate? Loss or gain?
Losses.
Losses. That means Below 10, that means the more volume taken inside the formation. For example, if you are pulling out 5 stand and this volume, you find 12 barrel. What this indicates? Kick or losses 12.
Two barrels loss.
No. I mean from 15, you drop instead of 10.
Oh, okay. 15,
you drop 12. To 12.
You get 12.
What this indicates?
That means you have an influx.
You have 2 barrel influx. Instead of you should fill 5 barrels.
Two barrels influx.
Yeah, you fill 3 and there is 2 coming from the well or from the formation. This is how to measure or you make your trip sheet. Look here, this is the trip sheet. Here, number for stand, size, and here the trip tank reading. Here the actual tank after pulling out. Here is the calculated barrel. The difference between D and E give you if you are lose or gain from this tank, from the well inside the tank. For example, if this one should be 3 and come 2 only, that means you have 1 barrel kick. If it is more, that means you have losses inside the well. But this strip sheet is very important in the rig location. Should be filled from the driller and checked by the company man and tool pusher and filed in the rig filing system. Okay, let's check this 2 simple calculation.
Okay.
First one.
Calculate the mud required to fill the hole per stand when pulling dry. Part capacity. So it's only displacement. So you take 93 feet and you multiply by the metal displacement 0.0083.
Yes.
0.78 barrels, 0.77 barrels, almost 1 barrel.
Yes. Example number 2.
Okay, and second one, calculate the mud required to fill the wholesale pulling wet. So that's both. So you take 0.1776 plus the displacement 0.0083. You get that multiply with 93 feet. You get 2.4 barrels. Okay. If you're pulling wet.
Yes. Can you check your formula sheet equation number 19 in formula sheet?
Formula sheet equation number 19 is pressure drop per foot tripping dry pipe.
When you're tripping dry pipe, how much pressure drop per foot? This is the equation equal to drilling mud density by 0.052 by metal displacement, all divided by casing capacity minus metal displacement for the pipe. This is first equation. Some questions or calculation can come in the exam for this question. Okay, so you look for wet or dry to select the correct equation. Number 20, the pressure drop per foot when you wet tripping.
Right.
Okay. Equation.
Important, huh?
Yeah, important. Yeah. Okay. Equation number 21 is talking about level drop when you're pulling the remaining collars or bottom hole assembly. The drill collar, I mean here, the bottom hole assembly out of the hole dry. This is the equation. Length for collar by metal displacement divided by the casing capacity.
Length of collars, only collars.
Collars that mean the bottom hole assembly, the BHA.
BHA, yeah. Length of collars and times metal displacement of the BHA divided by riser or casing. Okay. All right.
Equation number 22, the same equation for 21, but with level drop, pulling remaining cooler out of hole weight.
Hold on, Mr. Hani. 19, 20, 21, 22. Okay.
Equal
Level
to
drop.
length
22.
for cooler by times close-end displacement divided
Yes.
by casing capacity.
Yes. Okay.
Equation number 23.
Okay.
Length of tubular to pull dry before overbalance is lost. This is length per foot. This is the equation. Usually in the exam, he will give you the overbalance value, or you can get from the difference between formation pressure minus the hydrostatic pressure, the hydrostatic head.
Yes.
Okay. And equation number 24, length for tubular to pull width before overbalance is lost.
Okay.
The difference between metal displacement and the closed-end displacement in width tripping. Okay. This is all equation related to the tripping in calculation.
Right.
Last equation 29.
Okay.
If you look at 29, how much hydrostatic pressure loss if the casing float fail? You know the casing float.
Yes.
You can bump through it, prevent the flow inside. So when you're running
correct.
with casing, you need to fill the casing from inside.
Yes.
If the casing float fail, that means that you have U2 from annulus inside the pipe, inside the casing. So there is level, it will be dropped.
Yes.
According to the level, there is some hydrostatic pressure will be lost. You can get from this equation equal to mud density by 0.052 by capacity for the casing by unfilled casing height, all divided by casing capacity plus annular capacity.
Okay.
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 To this point, I will stop for 10-minute coffee break.
Okay.
What do you think? Okay.
Yes. Yes.
Okay.
I mean, yes.
After that, we'll continue, Sean.
Okay, Mr. Hani. Thank you.
Okay. Thanks.
Thank you.
Okay, back to our presentation again.
Yeah. Mr. Hani, you will give me this presentation after today. You will give me this presentation.
I will convert to PDF and give to you. No problem.
So I can study this tonight, huh?
Yeah. You can.
Yeah. Okay.
No problem. So if you are drilling with motor assembly, so you have float valve in the string. So how you can go up or tripping out with tripping? You need to bumping some called heavy slug inside the drill string. This is the benefit for pumping heavy slug. You start your pump. You start to pump length or barrel for slug, normally from 20 to 30 barrel, for example. It will sit inside the pipe. So after you shut down the pump, you have U-tube in the trip tank here, calculated, and you have empty or level drop inside the well pool. In the bottom here, from both sides, from annulus and drill string, bottom hole pressure will not change because the U-tube make balance inside the well. The increase in the slug weight will be compensated by level drop inside the well pool. So no change in bottom hole pressure. Here, the slug, the parallel coming out from the U-tube effect will be equal the parallel you will lose or the length you will lose or drop inside the drill string. That's why when you're pumping the slug or heavy slug, you must do flow check, routine flow check after you line up to the trip tank. Why? Because you know there is increase in the trip tank. So you know to monitor the increasing to confirm the well will be static after the U-tube effect finished or after you pump it the heavy slug. Normally the slug weight, the same properties for the mud, heavier than the mud weight by 1 to 2 ppg maximum, or from 10 to 15 BCF pound per foot square cubic foot. Here is useful to pump heavy slug before tripping.
Yep.
The bottom hole pressure will not reduce as the heavier mud will be compensated for the empty pipe. Bottom hole pressure when the bottom hole pressure start to increase once the heavy slug is coming out from the pit to the up.
Yes.
This is the start. You have effect on bottom hole pressure.
Right.
For pumping the slug, you have two equations here. Equation number 26 and 27.
26 and 27. Okay.
The 26 slug volume barrier for a given length of dry pipe equal length for dry pipe by pipe capacity by drilling density divided by slug density minus drilling fluid density.
Yes.
27 is the bit gain from the YouTube effect.
Yeah.
By barrier equal to slug volume by times slug density divided by drilling density minus 1. Okay, this is the two equations
Yes.
you can use in the exam or during calculation for the pumping slug. Could you check these two examples here, please?
Yes. Not volume, huh?
You need to calculate the volume for a slug. So this is equation in A. This is equation
26,
number
right?
26. Yes.
26.
Yeah.
Right?
Yeah, 26. Yeah.
Yeah. So length of once it you have three stands. You want to have 3 stands of drill pipe.
Yeah.
3 stands.
This is the minimum
so we don't
requirement.
convert this to feet, huh?
Yeah. This is we need to keep dry. So 3 stand.
Okay, so
by the
3 stand
length
convert.
for the stand.
90.
93
so 90
here. 93 here.
Yeah. Okay. So 93 feet. Okay. Yeah. What is 3? 3. What is 3? 3 is length.
3 is number 4 stand.
But why he put the stand there?
Because the equation 26 length of dry pipe by foot, right? In equation number 26.
He wants 3. He wants 3 stands, right, Mr. Hani? 3 stands.
Yeah,
right?
of dry to be dry. This is the length for dry
so
pipe. 93 times 3. It gives you how many feet of dry pipe. Times pipe capacity 0.0177 time mud weight 10.2.
Oh, yes. No, hold on. So the drill pipe. My problem is that the drill pipe is 3 stands. So each stand is 93, right?
Yes.
93 feet.
Yes. 3 stand. So this is number for a stand.
Okay.
Usually our target is to dry minimum 3 stand. Okay, when you pump slug.
Right. 3 stands and 93 drip pipe stand average length is 93 feet. Okay, understood. Okay. Yeah, correct. So 93 times 3 times the capacity the drip pipe capacity 0.0177. Okay. Times the pipe capacity, right? sorry, times the drilling fluid density. Yeah, times 10 point, 10 point, times 10.2 divide by slug density 11.7 minus the mud in the hole 10.2. 33 is the answer. 33.58.
Okay. Number B.
Number B, the slug was pumped. So the slug was pumped and the surface lines displaced with original drilling fluid after the slug. The trip tank was then lined up and the trip tank, the top drive disconnected, the slug allowed dropping. Okay. Gain volume trip tank. Okay, this should be volume gain. Volume gain should be after U-tubing is number 7. Slug density. Slug density 11.7. 11.7 divided by mud in the hole 10.2 minus 1 times 33.6. 5 barrel, 4.94. 5
Okay.
barrels.
Almost 5 barrels. Okay.
Yeah.
Check this two example.
A slug of heavy drilling mud is pumped into the drilling string before tripping out of hole. After balance, the bottom of slug is still in the drill pipe. What is the effect on the bottom hole pressure? Still nothing. Remains constant, B.
Yeah. Okay. Example
Okay.
number 2.
Heavy mud peel is being circulated around the well. When will bottom hole pressure start to increase? Then pressure loss in the well. When it exits the bit. Once the peel starts to displace into the annulus. Yeah. D. Once it goes out to the once it goes out into the annulus.
Yes. Okay.
Yeah.
After
that means when it's exiting when it starts exiting the drill pipe. The bit. Yeah. The bit. Yeah.
Okay. Here we'll talk about kick warning sign or indicators. This you can see when you are going into transition zone between normal formation pressure to abnormal formation pressure. The driller, when during drilling operation, can notice or see some parameters or warning sign. It can give you indication you may go, not must. You may go to kick situation or underbalance situation. That means he need to increase his awareness and his crew awareness also to notice if you are going to real kick situation or not.
Right.
This kick warning sign or indicators can happen during drilling phase or during tripping or circulation or connection time.
Yes.
During drilling, all the black or the black parameters is related to you may or might be go under banks. You are not sure. You may be. Sometimes this is like warning indicator. Like when you drive car with fast speed, you will find signboard, look, the stop or drive slowly. If you drive fast, it will not mean that you are sure to make accident, but it may be go to accident situation. This is the meaning also for these indicators. First indicator, while drilling, you will see your ROP increase, drilling rate increase. It's called ROP, rate of penetration. A sudden jump in ROP with the same parameters constant. You don't increase weight on bed or RPM or pump rate. And the driller, when you go to the transition zone, you will find ROP is going fast, like it jump from 50 foot per hour to 70, 80. This indicates you may go to high formation pressure or abnormal formation pressure. Why is the drilling rate increase or ROP increase? This sometimes is called drilling break.
Drilling break, yes.
Okay. Why this happen with abnormal formation pressure? Normal
because
formation, okay.
Because it's being pushed into the wellbore from the abnormal pressure, so it's breaking. So the bit is cutting. The bit can cut faster because it's becoming is pushing the formation, away from the well into the well bore. So your ROP will increase. You can cut better. So you will see your ROP start jumping, going up.
Is not exact answer, but usually 90% from the abnormal formation pressure has high porous area or medium. That means it is not heavy rock. When you break, you will break fast with high ROB. Like shale. Okay. So that's why your ROB is increasing with the depth. This is called real-time indicator. Once it has happened, you will see fast drilling at the steps. Okay. Second indicators, gas cut drilling fluid. This is coming from high pressure zone. You have drilled or solved gas coming inside the drilling fluid. This is called lagging indicator, delay indicator. You will see at the surface after circulation bottom up. Okay. Increased in chloride is lagging indicator. Why? Because when you are drilling with especially low chloride water-based mud, without adding any additives or chloride, you will see in the mud lab increasing or high increasing in chloride. This when you are drilling high salinity formation like shale or abnormal formation pressure. After that, increase in torque and the drag. The abnormal formation pressure is unstable formation. It makes caving during drilling. So you will have indication for high torque and the drag after connection. This can happen in normal formation. Yeah, that's why we said it is only warning sign. You go under balance or go inside of normal formation pressure. What you should do with the warning sign, the driller will stop drilling, go off bottom, and only make float check. If the float check is negative, that means everything is fine. He will increase his awareness and he will continue drilling. If the float check is positive, the well is flowing, he will need immediately, without any delay, to shut in the well without any permission. The driller has full authority to shut in the well without any permission from company man or tool pusher. After that, you will find here all will coming up except decrease in cutting or shale or rock density. Why there is decrease in rock density? Because the high pressure zone is high permeable zone, has high porosity. So when you weight up the sample from the formation at shale shaker, it gives you less than the normal formation. That's why there is decrease in rock density or shale cutting density. After that, you will find a change in the cutting and shape size for the cutting. You will have irregular size or shape for the cutting that indicate you are going to drill in unstable formation. Pump pressure will start to drop. Why? Because when the pressure for the formation becoming high, the overbalance was less, so the friction in the system become less, so the pump pressure little bit drop. This will be compensated by increase in all pump, increasing in stroke to compensate the reduction for the pump pressure. This can happen in all pump style. But in electrical pump now, the pumping pressure drop will not have increase in the stroke for the pump. So it will adjust the input power for the pump. This also real. So all parameters here increase except decrease in cutting and shale density and drop in pump pressure. This only two parameters drop. Also increase in flow line temperature. You have trend, you can measure at the surface, you have sensor as the flow lines return, measuring the downhole or surface temperature. The trend for temperature will be increased with the depth. Okay, but if you have high trend increasing in temperature, that indicate you may go to high pressure, high temperature zone.
Yes.
The red indicators here, red color indicators, this is real indicators, and positive called positive indicator. When you see one of them, you are sure you have kick. Without fluid check, you will shut in the well immediately.
Yes.
First, increase in the flow coming from the well. You have paddle type for sensor as the flow line to measure the percentage for the flow coming from the well. Okay, this is if this paddle coming up, that means increasing in the flow return from the well. That indicate you have kick situation. This give alarm to the driller and the captain. Stop, you have flow coming from the well. Pit gain, that means the tank level inside the tank, the mud, it will be increased due to the flow from the well. If the first indicator failed, so measuring tank all the time and record the level, it gives indication for the mud engineer or the crew that there is increase in the tanks while drilling. You will stop and shut in the well immediately. Third one, while make connection, the well start to flow with pump shut off.
Right.
During connection, this is you are sure you have kick situation. During tripping and connection, increase in the flow, the first one red, this real time and positive indicator. During connection, you have flow coming from the well, you will shut in the well immediately without any delay. After that, there is lagging indicators, trip gas, connection gas, background gas. You know from the mud logger surface, you have sensors at the flow line to measure the percentage for each types for the gas and give report to the company man during operation at least every 12 hours. So what is the difference between or the meaning between of trip, connection, and background gas?
Trip gas is when you stop the pumps and you break pipe to make new connection, either tripping out or tripping in. Connection gas is after you make connection, you start the pumps and you get the first bottoms up. That is maybe connection gas. Background gas is when you are drilling continuously and you have entrained gas in the mud system as you are drilling.
Thank you. Correct. Trip gas, this is coming when you pulling out, you have a swap. After you run back again to bottom and start your circulation, bottom up, you will have gas percentage while after tripping. This is called trip gas and sometimes called swap gas. Connection gas, this is when you make connection. What you lose when you make connection, you lose ABL value, anaerobic pressure loss. So at that moment, your formation pressure will be higher than your hydrostatic head. So slug or bubble or gas will come inside the well pore. So how you know? After you make connection, start circulation bottom up, you will have percentage at the surface for indicate you have connection.
Correct. Gas coming up. Yeah.
For gas connection, what you should do to eliminate this?
Gas on connection, you can what can you do? If a normal drilling, before you start pulling out, you can increase the mud weight by the percentage by the value of the APL before you come out.
Option if possible, increase mud weight.
Yes.
What also?
Increase mud weight. What else? What else can you do? If you have managed pressure drilling, that is different. But normal drilling, increase mud weight, and you can check slowly.
Minimize connection time.
Don't swap the formation. Minimize the pipe connect. Minimize. Okay, yeah, true. Minimize connection time also.
Minimize connection time. It gives you less time for connection, less slug volumes for the gas coming inside the well pore. And also, before you make connection, you circulate bottom up. So if you have gas in the well, it will come out. So only you will have minimum slug volume for the gas during the connection. So it will reduce the effect of the gas on the bottom hole.
Right.
And background gas, this is gas coming from normal drain from the formation. If the percentage from the background gas increase by the sudden way, this indicates you may go to abnormal formation pressure.
Yes.
And also you have tight well in connection. What means with tight well in connection? When you make connection, the formation start to back off around bottom hole assembly. So after you start pump, you have pull. You need to pull more to release your strain. This indication to unstable high formation pressure. In this case, you need to increase your mud weight to control the formation. And last thing is incorrect volume from trip tank. Indicate to the kick or swab during tripping.
Yes.
Clear?
Clear.
Okay. Let's look at these two examples, please.
Which of the following are indicators that a well might be going under balance? Two answers.
You need to answer here.
Yes, two answers. Going under balance. One is B, and a significant increase in pump pressure. Nope. A change in the size and shape of cutting. D. B and D.
B and D. Don't forget to look how many answers we need. Example number 2.
Which of the following should be considered as a kick indicator? Decrease in the drink fluid flow from the well? No. Hold on. Decrease in the drilling fluid flow from the well? No. Increase in drilling fluid density? No. Increase in solid content? No. Increase in the drilling fluid flow? Yes. D. D and E.
Okay. D and D. This is positive indicator.
Yes.
This one, the shape and size and the volume for the cutting.
Yes.
In some well, I know I have a lot of cutting. That's why we said this is warning sign only. Okay. So monitor by shaker man all the time as a shell shaker to give call to the driller first. So the driller, the first man, he need to be informed by any change in mass system or in cutting size or shape to react against the kick situation. Okay.
Right.
This is the flow line sensor, badal type.
Badal type, yep.
Here, when the badal type increase, the push more fluid. That means the sensor give you high level here.
Yes.
Normally, you adjust this sensor to have 5% up or 5% down the percentage for your flow.
Yes.
Here, this is the BVT or bit volume sensor inside the tank.
Yes. Yeah.
BVT is called bit volume totalizer.
Totalizer, yes.
You have another sensor. You adjust to plus or minus 2 or 3 barrel. If the difference here increase, so it give alarm to the
driller and
all the time. Please keep the alarm on for in the driller console. So it give indicator for the driller if there is loss or gain. And don't rely only on this sensor. You rely also in the tank level from the measurement.
Visual for the measurement,
From the measurement. This example.
Why is it important to monitor pip loader during a well control operation? To check for losses, to maintain bottom hole pressure constant, to adjust pump speed, to maintain bottom hole pressure constant, to follow the gas. I think two answers, right? To check mud losses. A is one. A is sure. To check for mud losses. B, no. C, to follow the gas expansion. Maybe.
Yeah, C also.
C.
Why C?
Bottom hole pressure constant.
When the gas start to expand, it will push more mud during killing operation out.
Yes.
So we need to measure the tank to follow this.
Follow this expansion. Migration.
This expansion.
Yeah.